Hey, Algebra 2 students. This is lesson 6, page 42, equations with decimal numbers and consecutive integer word problems. So if you have an equation that contains decimal numbers, it's really helpful to try to get rid of those decimals. And the way we can do that is just to multiply each of the terms of the equation by a power of 100 that gets rid of the decimal. So you'll see right here we have 3 places, 2 places, one place and 2 places right here. So if we multiply each of these terms by 1,000, that will move the decimal place all the way to the right in this first term, which will eliminate the decimals in every term. So I'm going to go ahead and do that. I'm just going to move in every term, I'm going to move the decimal 3 places. So that will leave us with 3x plus 400 equals 2050. All right. Then we're just going to solve the equation. We're going to move all the constants to one side. And then we're going to divide by the coefficient. And x will be 550. All right. So another thing that you should know in relation to the fractional parts of a number, decimals are also a part of a number. So if you write something like this as a like something like 2.0413 as a fraction, then we're just taking this and we're writing it over the power of 10 that indicates this many places. So this is going to be 10,000. So this is equivalent to this fraction, to this decimal. So that means we can use the fractional part of a number equation also for solving decimal parts of a number. All right, so if you look at example 6.2, which is on the next page, the students found that 15 thousandths of the teachers were either brave or completely fearless. If 300 teachers fell into one of these categories, how many teachers were there in all? Okay, so we're going to say instead of what fraction, it's what decimal of what number is what number. And this refers to the decimal part. This what number is the total of things. And this what number is the result. And then of means multiply, and is means equals. Okay, so if we say what decimal number, that's going to be 15 thousandths. And if we say we don't know what the total number of teachers is, that's the thing that's unknown. So that's what number. And then we know that 300 of the teachers fell into one of these categories. So that's what it's equal to. That's the result. So we're just going to multiply this times what number and divide both sides by the coefficient. So 300 divided by 0.015 is 20,000. So there are 20,000 teachers in all. All right, if we look at example 6.3, an analysis of the old woman's utterances show that 932 thousandths were vecticinal. If she spoke 2,000 times during the period in question, how many utterances were not vecticinal? So we have what decimal of what number is what number. We know that this represents the ones that were baptismal. I think baptismal means, if I remember right, I think it means like prophetic. Um, and the question saying how many utterances were not baptismal. So if this is how many that were, we need to take that and subtract it from one so that we can see how many are not baptismal. Because you could think of this almost like a percent, right? So if it was 100%, um, then it would be like around 93% were baptismal, and then so the other percent is not. So we're just going to subtract this from one. So 1 minus 932 thousandths. So that's going to be 68 thousandths are not baptismal. So that's the number we're going to use in our word problems because that's the one that we have the information for. That's the number we have the information for. So the total number of times that she spoke was 2,000. So that's the what number. And we don't know what the result is. We're going to multiply this decimal part of a number times the 2,000 times she spoke to find out how many were not baptismal. So times 2,000 is 136. So 136 of her utterances were not baptismal. Okay, moving on to 6b. This is consecutive integer word problem. So that means we have some number, and there is so it's an unspecified integer, and we're trying to find consecutive integers. So our form's going to be the first number is n, the second number is going to be n plus 1, the third number is going to be n plus 2, then n plus 3, and so on. So this is consecutive. But if we have consecutive even or odd integers, that's going to be the unknown number is n. And then consecutive even or odd, it's going to be n plus 2, n plus 4, n plus 6, etc. And it's the same for even or odd, and I'll show you why. Okay, so for consecutive, say our first number is 9, then 9 plus 1 is going to give us 10. 9 plus 2 is going to give us 11. 9 plus 3 is going to give us 12. So the consecutive, one right after the other. However, for consecutive even or odd, if I had an even number, let's say I have 4, 4 plus 2, 6, 4 plus 4, 8, 4 plus 6, 12, no, 10, sorry. You see that it's even amount of number, we're just going up by 2 each time. Well, that also works for an odd number. If you start with an odd number, 3, and you add 2 to it, that gives you 5. You add 4 to it, that gives you 7. You add 6 to it, that gives you 9, and so on. So if you have a consecutive even or odd problem, you're going to use this form. If you have a consecutive number problem, you're going to use this form. Okay, so let's look at one of these. Find 3 consecutive even integers such that 5 times the sum of the first and the third is 16 greater than 9 times the second. Okay, so find 3 consecutive even integers. So this is going to be this form right here. So I like to just go ahead and write these down. And it says the first 3, so I'm going to need n plus 2, and n plus 4. And I'm on example 6.4. on page 43. Um, the 5 times the sum of the first. So that's going to be 5 times the quantity of the first and the third. So that's the first is n and the third is n plus 4. So n plus 4 is, that's equal, 16 greater, so plus 16, 9 times the second. So 9 times whatever the second number is, which is n plus 2. Okay, so follow along with me one more time as I um, show you how I put this into equation form. 5 times, so 5 times the sum of the first and the third, so the first and the third, and then is, that means equals, 16 greater. I like to put that at the end so I don't get it confused. So plus 16, then 9 times, so 9 times the quantity of the second, which is n plus 2. Okay, now that you have that, we're going to eliminate the parentheses, combine like terms. We're going to move the variables, and then we're going to move the constants, and then we're going to solve. All right, so taking care of the parentheses first, we're going to, this is going to be 2n plus 4 here. Then we're going to distribute, so 10n plus 20. And then this is 9n plus 18 plus 16. Okay, combine like terms. 18 plus 16 is 34. Okay, I'm going to subtract 9n from both sides. That leaves me just n on this side. And I'm going to subtract 20 from both sides, which leaves me with 14 on this side. So what that tells me is that the first number, n, equals 14. That's not the complete answer, though. It asks us for the 3 consecutive even integers. So that's going to be 14. It's going to be 14, 16, and 18. It's going to be your answer. So you have to put all 3 of these there for it to be correct. Okay, and now let's look at page 44 at example 6.5. Find 4 consecutive integers so that such that 5 times the sum of the first and the fourth is 1 greater than 8 times the third. Okay, so 4 consecutive integers such that 5 times the sum of the first and the fourth is 1 greater than 8 times the third. So consecutive integers are n plus 1. This is asking for 4, so we're going to do n plus 2 and then n plus 3. So this is the first, second, third, and fourth. Okay, so 5 times the sum of the first and the fourth. So 5 times the quantity of n plus 3 is equals 1 greater, so plus 1, 8 times the third. So 8 parentheses times the third, n plus 2. Okay. We're going to go ahead and do the parentheses first. So this is going to be 2n plus 3. And that's 10n plus 15 equals 8n plus 16 plus 1. Combine like terms. It's 8n plus 17. Need to bring the 8 to the left, so I'm going to subtract it from both sides. Change signs, change sides, change signs. So 2n on the left, and then I need to bring this 15 to the right, so I'm changing sides there as well. So that gives me a 2. So the first integer is 1. And I need 4 of them. So that's going to be 1, 2, 3, and 4. All right. Go ahead and do the practice problems and pause the video. Go ahead and do the practice problems, and then you can check your answer. Okay. For for practice problem A, if this many were red dwarfs, then you have to subtract that from 1 in order to find out how many were not. So the 983 thousandths were not, and that would be multiplied by 29,000. So that would give us 28,507 stars for A. And then for B, the consecutive even integers are going to be n plus 2, n plus 4, those 3 integers. And we're going to multiply 3 times the sum of the first and third. So 3 times n plus 4. And that's equals 84 less, so minus 84, 12 times the second. So 12 times n plus 2. Distribute. So 6n plus 12 equals 12n plus 24 minus 84. Combine like terms, so 24 minus 84 is negative 60. Move variables to one side, negative 6n. And then I'm moving this 12 to the other side, so negative 72. Negative 72 divided by negative 6 is 12. So that's going to be 12. And the consecutive integers are 12. The consecutive even integers are 12, 14, and 16. Okay.